Graphing rational functions and getting overwhelmed? You're not alone. Today at Geometry, we're going through clear steps that put every piece together so that graphing rational functions just clicks. Let's get started. So today we have our function f of x equals x plus 1 all over x squared plus 6x plus 5. Now we all know, or hopefully we know, that our first step is always to factor first. So we are going to factor that denominator into x plus 1 and x plus 5. Now our second step is we're going to cancel common factors. By the way, guys, we have 9 steps, so grab a big piece of paper. I know this is going to be long, but it's going to really give you every little piece of information you need. So if you need to pause the video, copy down the steps, go for it. So we're canceling our common factors. So that is x plus 1. So we slash the trash, and then we are going to go straight to our whole. Some teachers do this differently. I like to do my whole because I'm thinking about my whole right now when I cancel my common factor, because my x value for my whole comes from that common factor. So I'm going to set that common factor of x plus 1 equal to 0, and then I'm going to subtract 1 from both sides, so I get my x value for my whole as -1. Now the next step is I'm going to simplify my equation. But what happened to the y value of my whole? We're going to get there. Just hang in there. So we simplify. Now, if you notice right here, we come down to here. Our numerator has canceled. We don't have anything up there. So we're going to put a 1 there. When something cancels out, we just put a 1. And now that we're going to finish up our whole. So we're going to take that -1 that was our x value, and we are going to plug that in to that x in our simplified equation. So here's that -1 being substituted in. And so y for our whole is going to be 1/4. So we put that together in step 6, and we're going to write that as a coordinate. So that is our whole. Now at this point, we are going to go straight over to our graph because we don't want to forget this. So we need -1, 1/4. So I'm going to go over -1, up 1/4. So it's going to be right about there. All right, there's our whole. That's done. Move on. Step 7, our vertical asymptote. This comes straight from our denominator. Now our denominator is that x plus 5, okay? So we are coming here, and we are going to go, let's see, where is that color? Here we go. So that guy is coming straight from there. So we set x plus 5 equal to 0. Again, same thing. Subtract 5 from both sides, we get x equals -5. So now I'm going to go over to my graph, and I'm going to graph my vertical asymptote. So I'm going to go over here. X is -5, and remember, when x is -5, we go 1, 2, 3, 4, -5. And we can't do a horizontal there because that would be our x-axis. So it has to be vertical, which is where we get the name from, a vertical asymptote. We're going to show that by making a dashed line. Okay, now we're going over to our horizontal asymptote. Now this has some special rules. Now I have a way of teaching this. If this looks like something you're interested in, you can just go over to my YouTube channel and look at the video specifically on how to remember horizontal asymptotes. So I have my examples from that video here, and if you look down to here, we have 1 over x plus 5. that's our simplified equation. Now, what tends to trip people up is that there's no x. So how do you figure out your degree? Well, anything to the 0 power equals 1. So I can actually put in that x to the 0 right there because it's just going to end up being 1. And now I can compare my x to the 0, x to the 1, and it is a bottom heavy. So that means that y equals 0. So I am going to grab my green. I'm going to go over to my graph, and it's going to be y equals 0. So horizontal, y equals 0. So we are going to go like this. And now I've sort of created four new quadrants. So I know that that's going to give me kind of a basic idea of where my hyperbola, which are that's the shape of our rational graph. Some teachers call them boomerangs, some people call them branches, swooshes, whatever your teacher uses, but they have a shape of a hyperbola. All right, so now what do we do after step 8? And again, if you need to, pause the video, write these down. We're going to open up our graphing calculator. Now I have an app that I'm going to be using, and it mimics the TI-84CE, but the instructions I'm going to give you will work on the TI-84 Plus. So we're going to open our graphing calculator, and I'm going to pull that over here. We're going to click y equals. So we're in that. Let me just go back out. So we click y equals. And then we need our fraction. Now this will work on any TI-84 and up. So we're going to go alpha y equals, and we're going to click the number 1 that says numerator denominator. So now we have a nice fraction. So let's go over to that simplified equation in purple. So that was our 1 over x plus 5. So I'm going to go 1, arrow down, x, which is under our mode key next to alpha, x plus 5. Okay, now I like to tell students that before they do anything, we are going to click the graph so we can kind of get an idea of what the shape or the location of the hyperbola, aka branches, swooshes, is going to be. So I'm going to bring that back out, and I'm actually going to make it, I'll keep it anchored there. So we're going to graph, and I'm going to zoom out a little bit. And now we can see that we are going to have a swoosh in that bottom left and then in that top right. So that gives us kind of an idea of where we're going to be sketching our graph. Now we're going to switch over and get some points. So we're going to get a function table, and we're going to do that by clicking on second graph. And now when you do that, when you scroll through your points, you're going to see where it'll say error. That's your vertical asymptote. So that's a great way to check to make sure that your vertical asymptote is correct. So let's go to second graph. And our vertical asymptote, let's look for that error. There it is. Okay, so we've got that error at -5, and that is where our vertical asymptote was. So let's grab some points here, and we're going to do some points on one side of that error and some points on the other side. So let's go with, I like that -6 and -1. So I am going to zoom out here so that I can, and I will just bring that guy over here now. Okay. So let's see, what color should I do this in? How about a light blue? That'd be nice. If I can make this work. Oh no, come back. There we go. Okay. So I'm going to -6, -1. So 1, 2, 3, 4, 5, -6, -1. Okay, there we go. And that is in that kind of bottom left quadrant that we've created. And then we've got -7, -1/2. So -7, -1/2. And if we wanted to, we could go, okay, let's do -8, -1/3. So we are approaching that asymptote. And remember, the graph of a rational function, it's going to kind of be like a ball that rolls up against a fence. It doesn't roll on top of the fence, but it's going to roll all like right up against it. All right, so we don't really have anything from our calculator between -6 and -5, but we know it's going to approach our asymptote. So we can just kind of sketch that guy out and just kind of do one of these. Yeah, let's try it again. That was not pretty. How about we do it in 2? So we'll go like that, and then we'll go like this. All right, that's one of our boomerangs. Now let's go over to the other side. So I've got -4, 1. So 1, 2, 3, -4, 1. So there's that guy. -3.5. And then we've got -2 1/3. And then that -1 was actually at 1/4. So now we have enough, and we can see that this is going to be approaching, and then it does use that hole as kind of a point to go through. And then we just sketch this going up towards that asymptote. And if we go back to our graph, yeah, that looks pretty good. That's pretty close. And that is how we graph our rational function. I hope that helped. If you need more help, check out Steometry on YouTube. And if you can hit that like and subscribe buttons, that'd be amazing. Have a great one, guys.